We're not crazy. Water reacting with water, this does happen. Doesn't happen a lot, but it does happen.
Does it happen?
Like 1 times 10 to the negative 7th.
Why does it happen?
Oh, so when these two waters interact at just the right speed, at just the right angle, they will cleave each other apart. If one hydrogen comes in at just the right angle, it's going to feel pressure from another oxygen, and for a very short moment, it's going to hang on to that oxygen and leave its guy behind, and that's what you get. So one of these waters is acting as an acid. You make it whichever one you want. The other one, accepting the hydrogen, is acting as a base. The way I've drawn this one would be acting as your acid. That one would be acting as your base. If this starts out as your acid here, the conjugate base of that, so the guy who lost the hydrogen is this guy. So he's your conjugate base. He would gain back that hydrogen to come back across, and having given up the hydrogen here, this would be your conjugate acid.
So where does it come from?
All the time, everywhere. And the water you drink, that reaction's happening.
Why is it important?
So our entire pH scale is based off of this reaction. So the reason we say certain things are acidic and certain things are basic is because the thing that's actually dissolving them has its own equilibrium reaction going on. So water inherently has a neutral pH. You see, every time you put two waters together, you get an equal amount of acid and an equal amount of base. So water is inherently rigged to be able to take on and dissolve either bases or acids. It's perfect solvent. Absolutely perfect. So that's why it can dissolve acids and bases, because it has some acid and some base already there. Very small amount, but already there. So in large amounts of water, it can dissolve just about anything, acidic or basic. But that equation is called the autoionization of water. It happens with no influence needed from anything else. It happens all by itself. And as you get later in the class, in the first part of Chem 2, that is the basis for our pH scale. That's why milk is neutral pH and something like phosphoric acid is a slightly acidic pH. And how far did he get? Did he get to neutralizations?
No, he stopped there.
Okay. Do you have any questions about anything we went over today? I can do a little bit of neutralization if you all want to see it. We still got about 15 minutes.
Sure. So are we gonna have empirical formulas on our exam?
I don't know. From what he and I had talked, we were thinking, or he was thinking about trying to bring that in when we do equivalence. So assuming we stay on schedule the rest of the course, you'd have equivalence on test 5. He's thinking you do it then, because you can really easily tie in empirical formula and equivalence to each other. So for neutralizations, they work with very specific things. So you always have to have an acid, you always have to have a base, and they make a salt in water. Okay, so this acid reacting with this base, this is going to give a hydrogen to that. One hydrogen, that's all it's got to give. When it gives it to this, if you watch, when you cleave apart this water, what you have here is a hydrogen and a hydroxide, right? 2 hydrogens, 1 oxygen. But they formed by taking this acid, this acidic hydrogen, and slamming it with that hydroxide. Okay? Same thing here. But what you made is if you have 2 hydroxides here and 2 hydrogens here, you will make 2 water molecules. That's because each one of those water molecules is made up of a hydrogen and a hydroxide. Okay? So if you put them together in the same quantities, you're going to get the same amount of water. So what you want to distinguish with these is they can be one-way or two-way arrows, just like everything else. You will have a one-way arrow if at least one of the reactants is strong. So you need to look at both the reactants. Is this a strong acid? Is phosphoric acid a strong acid? No. So this guy isn't going to do it. What about potassium hydroxide? Is potassium hydroxide on our list of strong bases? Yes. This guy, by himself, makes this reaction a one-way arrow. Okay? If it's not for him, it's a two-way arrow. So one-way arrow because of this guy, strong base. Now then, we want to have the same amount of hydrogens as we have hydroxides. Right now, how many hydroxides do we have? Just one. And how many hydrogens? Acidic hydrogens? 3. I need 3 hydroxides. Okay?
So wait, you balance it before?
You have to balance on the fly with these, otherwise it will murder you in the end. Yes. So 3 hydrogens and 3 hydroxides make 3 water molecules. Okay? 3 to 3. So those are all gone. So now your hydroxides are gone and your hydrogens are gone. What is all that's left?
Potassium and phosphate.
And it just works out so perfectly that the charge on phosphates minus 3, the charge of each of those potassiums is plus 1. So I need 3 potassiums for every phosphate. If you balance on the fly like that, it's so much better. You can do it at the end. If you choose to do it at the end, you need to balance with hydroxides and hydrogens, not hydrogens and oxygens. Okay? What about this one? Is magnesium hydroxide a strong base? No. Is nitric acid a strong acid?
Yes.
Yes. So this is a one-way arrow because of the acid this time. Okay? This has 2 hydroxides. This only has 1 hydrogen. So I need 2 hydrogens there. 2 hydroxides, 2 hydrogens give me 2 waters. What's left? So these are gone. All I got left is a plus 2 magnesium and 2 minus 1 nitrates. So you're going to put those together. And you'll get magnesium nitrate. Okay, so on this one here, strong acid, weak base. Everyone see that? Strong acid, sulfuric acid, weak base, titanium 4 hydroxide. It's going to be a one-way arrow because of that strong acid. 2 hydrogens, 4 hydroxides. You need a 2 in front of that to get 4 hydrogens.
So it only takes 1 strong acid for it to be one way.
Yes.
How if you had 2? If you had 2 strong.
Then it's really one-way arrow, but you can't make it any more than just a one-way arrow. If both of them are strong, like what you had up here, it's simultaneous. It'll happen with a matter of milliseconds. The moment this touches this, it's already reacted. You'll see the salt start snowing in the bottom of your beaker. With something like this, however, where both of them are weak, it may happen over a period of days. It takes a lot of time for that solid salt to form. So if you've got 4 hydroxides here and 2 hydrogens here, I need a 2 in front of that to get me 4 hydrogens. So 4 hydrogens, 4 hydroxides are going to give you 4 waters. What you have left then is 2 sulfates and 1 titanium. So your titanium is plus 4, your sulfates are each minus 2, and you have 2 of them. Now, all these have had at least one that's a strong. Now, when you have both of them that are weak, you have a 2-way arrow. That's the only way in a neutralization you can have a 2-way arrow, is if both the acid and the base are weak. Okay? 2 hydrogens, 6 hydroxides. I need 6 hydrogens here. So if I put a 3 in front of that, that'll give me 6 hydrogens. 6 hydrogens, 6 hydroxides, 6 water molecules. What I have left then is 3 carbonates and 1 uranium plus 6. So you get a uranium, carbonate, salt. Everyone okay with those? Do you have any questions about how to figure out the balancing on the fly?
No, but I do have a question about the first one. So the first one has a,
Weak acid
okay,
and a strong base.
strong base. Okay. So you
Yeah.
either have to have a strong acid or a strong base.
You have to have one in order to make it a one-way
Did he
arrow.
make a list of the strong bases already?
Yes. So your strong base is, if you start at lithium hydroxide, so lithium hydroxides and hydroxides of lithium, and going down,
And then
So that-
calcium.
and then calcium hydroxides, and the guys under it are your strong bases. So the exceptions to that are obviously just hydrogen, because that would just make water, and then beryllium hydroxide and magnesium hydroxide. And then of course everyone else that's not in those two columns under that. So you gotta have one of these guys or one of your 7 over there.
And all the transition elements are weak.
Weak. And all your other acids are weak except for those 7. Yep. May have enough time to do the ammonia like salt. So in this case, strong acid, weak base. Strong acid makes it a one-way arrow. So you get the hydrogen leaving this, coming to the ammonia, making ammonium and bromine. In this case, strong acid again, weak base, making ammonium sulfate salt. So there's no water as your leftover product when you're reacting ammonia with an acid. There's no leftover water. Okay? So in this case, one hydrogen, remember, one hydrogen can come off of that phosphoric acid at a time. For every hydrogen, you need an ammonia, okay? 3 hydrogens, you need 3 ammonias, okay? 3 ammonias and 3 hydrogens will give you 3 ammoniums. It's 2-way arrow, weak acid, weak base. 3 ammonias, 3 hydrogens, 3 ammoniums. And what you have left after that is just a phosphate. Now, there's 2 ways you can write this. If you're more comfortable writing that with charges, then do it that way. Another acceptable way to write this is as a salt compound, where you're taking those 3 ammoniums that have a +1 each and packing them onto that phosphate. Either one's acceptable, yeah.
How do I know if it's acid or base again?
If it's an acid, it's going to have a hydrogen in front.
Okay.
If it's a base, it's either going to have hydroxide or it's going to be ammonia,
What is ammonia?
NH3.
Okay.
So ammonia is your only base that does not have hydroxide. It's kind of like your exception for the bases. So I may have enough time for one more. So this one right here, weak acid, weak base, 2-way arrow here. 2 hydrogens, only 1 ammonia, so you need 2 ammonias there. 2 hydrogens, 2 ammonias, give you 2 ammoniums. What's left behind here is just this carbonate. Another way to write that, just doing this half of the reaction, another way to write that is making it a salt. So you've got 2 ammoniums here and a carbonate. So an ammonium carbonate salt. Whichever way it's easier for you to see it. If it's easier for you to see it as the charge is separated here or is combined as a single salt. Either way is acceptable. Okay. Any other questions on anything from last class? Know your strong acids, know your strong bases. If you don't, start flashcarding and studying on them.